All right, we're going to be looking at 757 here. Let's do part A first. 10.5 grams of a gas occupied 2.1 liters at STP. What is the molar mass of the gas? Well, what we need something that relates our mass. Whoops, what did I do there? We need something that, oh my word, I'm about ready to go crazy. All right, we need something that relates our mass of our gas to a given number of moles. Well, we have that with our volume and our temperature and our pressure of 1 atm. So we've got piv inert. So we have 1 atm times 2.10 liters times 0.0821 times 273.15. So we can solve for a number of moles, and that gives us 2.1 divided by 0.0821 divided by 273.15 equals 0.093, that's a 6 moles. So to get the molar mass, we're going to take that 10.5 grams, divide by 0.0936 moles equals 112.1 grams per mole is what I am getting. And I should have talked a little bit more. Why did I do this last step? Well, notice we want to have units of grams per mole per answer. And we just solved for a number of moles here that is related to that many grams. So you could think of it as, if 10.5 grams is that many moles, then how many grams in 1 mole? So there's your answer for A. So let's take a look at B now. Alright, so let's take a look at part B. .783 grams of gas occupies 885 milliliters at 1.2 atm and 24 degrees Celsius. This is the exact same as the last problem, except they're making us jump through a bunch of more hoops. So we've got a volume this time of 885 milliliters. So to use piv inert, we're going to have to convert to liters. So our volume is going to be 0.885 liters. Then our pressure, hey, they gave us pressures in units that were nice. Yay us. And then our temperature, they gave us to us in that evil of all scales, Celsius. So we're going to have to convert to Kelvin. And that's 792, so 297 K is now our temperature. So now it becomes just a matter of doing the math. We've got piv inert. I moved too fast for the computer to keep up. Alright, there we go. 1.20 atm times a volume of 0.885 times 297. So 1.20 times 0.885, and I'm getting rid of units because I'm working with a stylus and it's clunky. So anything less that I have to write simplifies the process for me here. Equals my number of moles. So there's our number of moles. Now we're wanting molar mass, and we know that that number of moles is related to that many grams. So 0.783 grams divided by 0.0436 moles. And this is going to be a pretty big gas here. Oh, no, it's not. Just 17.97 or 18 grams per mole is going to be our answer there. I don't have the answer key, so I'm actually punching it in, making sure I got my answer right here. Yeah, I got my answer right. All right, let's try one more here. For that, I'm going to add an extra slide. Where's my extra slide button go? Whoa, what happened there? Oh. All right. Everybody's still with me, I hope. Let's add another picture here. And part C. Alright, so we've got our part C here. 2.24 grams of a gas occupies a volume, a pressure, and a temperature again. So let's go through it. We've got a volume given to us in correct units this time, 1.23 liters. We've got a pressure that's not given to us in the correct units for Pivnert. So 655 torr times 760 torr per 1 atm. And that gives us a pressure that we're going to use of 655 divided by 760 equals 0.862 atm. Oh, and our temperature, why do they keep giving us Celsius when they know we're just going to go ahead and convert to Kelvin? So we're going to plug into Pivnert with a pressure of 0.862 atm times a volume of 1.23 liters times 0.0821 times a temperature of 298. Once again, I'm not writing units because, well, I'm working with a really old stylus and a really old device today instead of one of my newer ones. And that gives me 0.043 3 for my number of moles. And they told us that 2.24 grams has that number of moles. And that's going to give me an answer of 51.7 grams per mole. Correctamundo. That's it. Beep.